Hi everyone, welcome to the fourth and last video of this simple airflow analysis and track comparison between conical and tangent ogive NOSECONE. In this video, we will visualize the result of the simulation, or we can say we will do the post-processing or CRP post. Let's double-click the results of conical NOSECONE first. So we need to understand that there are multiple ways to visualize the results. We can get different results from simulation, as well as we can get the same results in many different ways. So in this video, we will be limited to 4 or 5 ways of visualizing the results that we have obtained. So we will calculate the drag force on NOSECONE, we will make a streamline flow, we will plot pressure contour over the NOSECONE and rocket body, and we will plot velocity and pressure contour at a plane passing through the center of the rocket. So first of all, to calculate the drag, we can go to expressions and click drag and go to evaluate and evaluate the expression. So we find that the drag value for conical NOSECONE is 5.94464 newtons. In the same way, we can create contours and streamlines just for conical NOSECONE, and then go to tangent ogive NOSECONE and do the same. So what I'm trying to say is you can do the individual post processing for each NOSECONE if you have many number of NOSECONEs, or you are just performing the simulation for a single NOSECONE. Since we are doing the simulation for two NOSECONEs simultaneously, what we want to do right now is we want to visualize both the results together. So like I've said, we can do the post-processing individually also, but for this video, let's do the post-processing together. So close this results, and from the component system, find results and drag this here. So drag the solution of each NOSECONE to this result and open this result. So here we will be able to see both the NOSECONEs here. Let's decrease this and let's make them full size. Okay. So let's first of all let's calculate the drag force. We can go to expression and click drag force and go to evaluate. Now for conical NOSECONE, it's 5.94464. 5.94464, and for tangent NOSECONE it's 5.7529929. Let's subtract it to see the difference. 5.75929. So if we see this in terms of percentage, it is divided by 5.94264. So it's almost like 3.1% decrease in drag just in the NOSECONE. So we cannot only draw a conclusion from just this data. There might be some other repercussions in the maybe in the pressure concentration, as well as in the flow disturbance down the flow. So those things should also be considered. But however, if we consider only the drag contribution of NOSECONE, there is a 3% decrease. There is about 3% decrease when we change the profile of NOSECONE from conical NOSECONE to tangent ogive NOSECONE. So let us consider that we hadn't set up this expression before in setup. So then in that case also we could have calculated the drag force, for which we go to calculators and click the function calculator, and in function we click force, and in location we click NOSECONE and global x. So we are calculating the force in x direction, and in tangent ogive it is 5.75, do not clear, and in conical it is 5.94. So we can we get the same value either from calculator or from our expression. So now let's make the streamline flow. So for that we go here, it is called streamline. So the streamline means like we have some certain seed points at certain phase, and we will track where the fluid from that point will go in the domain. So make it 3D streamline and start from inlet for both. So we have selected all domains. So we will click apply. Let's increase the number of points to 50. So there are certain differences between these two. Like there is a green streamline here, there is not a green streamline here, but we cannot actually quantitatively tell the difference by just looking at the velocity streamline, right? So we can see at the uh, legend view. So here the values are in scientific notation, which is kind of disturbing. So let's change that. Double click the legend view, and in appearance make it fixed, and the precision make it up to 1 decimal point. That's a big one. So the streamline flow, if we want to save the streamline flow, we can go to uh, this camera icon and select, maybe I want to select a node screen here, and streamline. So I'm save, save. And so this image is saved there. So now let's plot the pressure of node cone in body. For that we go to contour. Let's all domains, not only body, we want to select node cone as well for both the domains. So I hold the control and selected these faces, and let's click OK. Okay, so we can see a lot of differences here. So let's hide the streamline view, and also let's hide the wireframe and rotate this in this way. Rotate this also this way. So the difference is pretty. There is a pretty much difference between these two in terms of pressure. So we can visualize the difference. So we can see that in conical nodes, then there is a very low pressure at the neck, whereas in tangent ogive nodes, there is no such low pressure concentration, but there is a high pressure concentration at the tip, which is greater than that of the conical nodes one. So we can save this image by going here in the same region, same place, same folder. You can save it as pressure contour over NOSECONE. Save, save. Okay. And similarly, like for another point, which is in a mid plane, we can create a plane by going to location and clicking plane. So we want a XZ plane, XZ plane, apply. So we'd like to plot pressure and velocity over this plane. So for that we go to contour, and instead of body we select plane 1 and maybe increase the contour and click OK. So we can see it's not increasing, let's make it 10. So we can see the pressure contour at this region. So let's hide the contour 1 to visualize this, and maybe show the body and NOSECONE so that it looks better. Okay. Yeah. So let's also change the configuration from here, because we can visualize the data better in this way. And maybe click Y to orient the views. Yes. So we can see the difference in the pressure contour in the region. So here is a concentration of pressure, whereas there is no high pressure concentration in conical NOSECONE. But there is a low pressure region in conical NOSECONE, whereas there is no such low pressure region in tangent ogive NOSECONE. So we can again save this by going here, and we can say it's pressure contour in midway. Let's save. So also inside of pressure we can visualize the velocity. So there is also a difference in velocity plot in the mid plane. We can also save this as velocity contour. Save. Okay. So if we want to visualize just one, not two, even when we have already like merged the result in the workbench, what we can do is maximize one and just see the result here, and maybe like save the results for this by going to, let's change the default appearance, make it fixed, make it 1. It doesn't look good that way. So now we can go to here and we can say velocity, contour in mid plane for tangent, ogive, NOSECONE, or any name you can give it. It's a pretty long name. So, so So in this way, we visualize the results of the tangential nose cone and conical nose cone. So there are some differences. We can quantify these differences, and we can also follow this same steps with other type of nose cones. And so, like I've said before, we need to perform a lot of other result visualizations, as well as to validate the result we have to do comparison and mesh independence study. So maybe we will go through further detailed study in our further videos. So for this series, uh, I would like to complete this series with this simple analysis of conical and tangential nose cone. Thank you for being with us for the with the videos. And if there's any problem, please let me know. Thank you and see you.